Welcome. In this video, we'll embark on a journey through Jetpack Compose Essentials. Whether you're an experienced Kotlin developer or just starting out, this guide will help you master building Android applications using Jetpack Compose, Android Studio, and Kotlin. We'll begin with the basics, setting up your development environment, and gradually move to advanced topics like custom layouts, state management, and animations. By the end, you'll have a solid foundation for creating modern, responsive Android apps. Let's dive in and discover what makes Compose a game changer for Android UI development. Pack Compose Essentials is designed for both seasoned Kotlin programmers and those new to the language. If you already know Kotlin, you can focus on the Compose-specific chapters. If you're just starting out, don't worry, the book in this video will guide you step by step, from the basics of Kotlin to advanced Compose features. No matter your background, as long as you have basic programming experience and access to a Windows, Mac, or Linux system, you're ready to begin building Android apps. Help you learn by doing. All the source code and Android Studio project files used in this guide are available for download. You'll find instructions on how to open these projects in Android Studio, so you can follow along and experiment with the examples. This hands-on approach ensures you not only understand the concepts but also gain practical experience building real apps. For learning, experience matters. If you encounter any errors, have questions, or want to share feedback, support is just an email away. The book's authors encourage you to reach out with any issues or suggestions. Additionally, an errata page is maintained to address known issues and provide solutions, ensuring you always have the most accurate information. Before you start coding, you'll need to set up your development environment. This involves installing Android Studio, which includes the Android SDK, Kotlin plugin, and OpenJDK. The process is straightforward and covered for Windows, macOS, and Linux. With the right setup, you'll be ready to build, test, and run Android apps efficiently. To ensure smooth development, your system should meet certain requirements. Android Studio runs on Windows 8, 10, 11, macOS 10.14 or later, Chrome OS with Intel i5 or higher, and Linux with glib 2.31+. You'll need at least 8 GB of RAM and 8 GB of disk space, though more memory is recommended for better performance, especially when using the Android Virtual Device Emulator. Android Studio is the main tool for Android development. Download the latest version from the official website. If you need a specific version such as Bumblebee 202111, you can find it in the archives. Always check for the latest updates to ensure compatibility with the examples and tutorials. On Windows, installation is as simple as running the downloaded executable and following the setup wizard. Choose your installation location and ensure both Android Studio and Android Virtual Device options are selected. After installation, you can launch Android Studio from the Start menu or pin it to your taskbar for easy access. For macOS users, Android Studio comes as a disk image (DMG) file. Simply drag the Android Studio icon into your Applications folder. You can then launch it from Applications or add it to your dock for quick access. The installation is fast and integrates seamlessly with macOS. Linux users can install Android Studio by unzipping the downloaded package and running the Studio sh script from the terminal. You may need to install some 32-bit support libraries depending on your distribution. Once installed, you can launch Android Studio from the terminal or create a shortcut for convenience. First time you launch Android Studio, a setup wizard guides you through configuring the SDK and other essential components. Select the latest API package and follow the prompts. If you're upgrading from a previous version, you can import your old settings or start fresh. Once setup is complete, you'll see the welcome screen ready for your first project. After installing Android Studio, it's important to verify and update your SDK packages. Use the SDK manager to check which versions are installed and add older versions if needed. This ensures your apps are compatible with a wide range of devices, including those running Android 8 Oreo and above. In addition to the SDK, you'll need several tools for building and testing apps. Check the SDK Tools tab for essential packages like Build Tools, Emulator, Platform Tools, and more. Install or update any missing tools to ensure your development environment is complete and up to date. Sometimes, you'll need to use Android SDK tools from the command line. To do this, add the SDK Tools directories to your system's path environment variable. The process varies by operating system, but once set up, you can run tools like a DB and AvManager directly from your terminal or command prompt. Android Studio allows you to adjust memory settings for optimal performance. If your system has more than 8 GB of RAM, consider increasing the memory allocation for both the IDE and build processes. This can significantly speed up your workflow, especially when working on large projects or using the emulator. Stay current by regularly updating Android Studio and the Android SDK. The IDE will notify you when updates are available, but you can also check manually. Keeping your tools up to date ensures compatibility with the latest Android features and security improvements. With your environment ready, it's time to create your first Compose project. The example project includes 2 text components and a slider. As you move the slider, one text component updates its value and the other adjusts its font size. This simple app demonstrates Compose's power and flexibility and verifies your setup is working. Launch Android Studio and select New Project. Choose the empty Compose activity template, which is pre-configured for Compose development. Set your project name, package, and minimum SDK version. Compose projects use Kotlin by default, ensuring you're ready for modern Android development. In Android, an activity represents a single screen or module of your app. The main activity class is the entry point, containing the code for your app's first screen. Compose uses composable functions to build UI elements, making your code modular and reusable. Main activity, KT file starts with a package declaration and import statements for necessary libraries. The onCreate method sets up the UI using setContent and calls a composable function to define the layout. The Compose demo theme composable applies your app's theme, while Surface provides a background for other UI elements. Composable functions are the building blocks of Compose UI. Marked with the @composable annotation, these functions can emit UI elements like text, buttons, or custom layouts. For example, the greeting function displays a simple text message, demonstrating how easy it is to create reusable UI components. Compose's preview feature lets you see your UI without running the app on a device. Annotate a composable function with @preview to render it in the preview panel. You can even enable system UI decorations for a more realistic look. This speeds up development and helps you iterate quickly. Compose's preview panel supports live editing and interactive mode. As you change code, the preview updates instantly. Interactive mode lets you test UI interactions like moving sliders or clicking buttons directly in the preview, making it easier to fine-tune your app's behavior before deploying to a device. Let's create a custom composable called demo text. This function takes a message and a font size displaying the text in bold. By passing parameters, you make the composable flexible and reusable. Import the necessary libraries for font weight and size, and you're ready to add dynamic text to your UI. Add a @preview annotated function to see demo text in action. Change the message or font size and watch the preview update instantly. This rapid feedback loop helps you perfect your UI components before integrating them into the main screen. The demo slider composable adds interactivity to your UI. It takes the current slider position and a callback for handling changes. Using Compose's slider component, you can easily create a range-based input that updates as the user interacts. Modifiers like padding help you fine-tune the layout. Compose uses state to manage dynamic UI changes. The remember function, combined with mutable state of, lets you store and update values like the slider position. This ensures your UI responds to user input and maintains its state across recompositions. Demo screen brings everything together. It manages the slider's state, handles position changes, and arranges components vertically using a column. You'll see demo text, a spacer, demo slider, and a text component displaying the current slider value. This structure demonstrates how composables can be combined to create complex layouts. Add a @preview function for demo screen to see the complete UI in action. Enable system UI decorations for a realistic look. Use interactive mode to test the slider and watch the text update in real time. This step confirms your layout and logic work as intended. Update main activities onCreate method to display demo screen instead of the default greeting. This ensures your custom UI appears when the app runs on a device or emulator, not just in the preview. Now your Compose app is ready for real-world testing. To fully test your app, use the Android Virtual Device (AVD) emulator. The emulator lets you simulate different devices, screen sizes, and hardware features. Create and configure an AVD using the device manager, then run your app to see how it performs in a real Android environment. Launch the device manager in Android Studio and select Create Device. Choose a device template like Pixel 4 and select the desired Android version. Customize hardware options as needed. Once created, your AVD is ready for app testing and debugging. Start your AVD from the device manager. The emulator can run embedded in Android Studio or as a separate window. You can switch between device orientations and manage multiple emulator sessions. This flexibility helps you test your app in various scenarios. With your AVD running, select it as the target device in Android Studio and click the Run button. Your app will compile, install, and launch in the emulator. Watch as your Compose UI appears, ready for interaction and testing. Android Studio lets you run your app on multiple emulators or physical devices simultaneously. This is useful for ensuring your app works across different screen sizes and hardware configurations. Select the devices you want to target and run your app in parallel. To stop a running app, use the Stop button in the Android Studio toolbar or the Run tool window. You can also manage running apps directly from the emulator. This gives you full control over your testing sessions and helps you troubleshoot any issues. Android 10 introduced dark theme support, and Compose makes it easy to test. Enable dark theme in the emulator's settings and rerun your app. Your UI will automatically adapt, letting you verify that your app looks great in both light and dark modes. You can run the emulator as a tool window inside Android Studio or as a separate window. Choose the mode that fits your workflow best. detach or float the emulator window for more screen space or to work on multiple monitors. Customize the emulator's appearance by enabling or disabling the device frame. This lets you see your app as it would appear on a real device or focus on just the screen content. Adjust these settings in the device manager for each AVD. Advanced users can create and manage AVDs from the command line using AVManager. List available targets, create new devices, or delete and move AVDs as needed. This is especially useful for automation or scripting in larger projects. Each AVD stores its configuration in files under your home directory. You can edit these files directly to change settings like screen size or memory. Just remember to refresh the device manager after making changes to ensure they take effect. You can rename or move AVDs using the AVManager tool. This is helpful for organizing your development environment, especially if you work with multiple projects or need to share configurations across systems. You've now set up your development environment, built your first Compose project, and tested it on an emulator. With these foundations, you're ready to explore more advanced Compose features, create custom layouts, and build fully featured Android apps. Continue learning and experimenting to unlock the full power of Jetpack Compose. Practice is key to mastering Jetpack Compose. Try modifying the example project, adding new components, or experimenting with different layouts and themes. The more you build, the more confident you'll become in creating modern, responsive Android UIs. Congratulations on completing the Jetpack Compose Essentials introduction. You've taken important steps toward becoming a proficient Android developer. Stay curious, keep building, and enjoy the creative process of designing beautiful, functional apps with Compose.